Hello friends, today we are going to see what is magic square and the program for magic square. So let's see. As you can see, this is the magic square and this is a matrix. In this case, this is a 3 by 3 matrix. So a magic square is a two-dimensional array. So let's see what are its properties. What makes it a magic square? So these are the properties. See, the first property is addition of every row, every column and both diagonals is a same constant. So let's see what does this mean. So see here, suppose you add all the elements in the first row. So see, 2 plus 7 is 9, 9 plus 6 is 15. Okay. Then second row, 9 plus 5 is 14 plus 1 is 15. Then third row, 4 plus 3 is 7, 7 plus 8 is 15. See, the addition is same. Okay. Then the columns now, 2 plus 9, 11 plus 4 is 15. Then 7 plus 5 is 12 plus 3 is 15. 6 plus 1 is 7 plus 8 is 15. See, all the columns have same addition and both diagonals. See, these two diagonals. So 2 plus 5, 7 plus 8 is 15. Then 6 plus 5 is 11 plus 4 is 15. So the addition is same for every row, every column and both diagonals. And that addition is constant. And what is that constant? See, that addition will be n into n square plus 1 by 2. Now in this case, n is equal to 3. So see here, 3 into 3 square plus 1 by 2. Let's do that. 3 into 3 square plus 1 by 2 means, see, 3 square is 9. So 9 plus 1 is 10. 10 by 2 is 5. So 3 into 5. So that is 15. So 3 into 5 is 15. So that addition is a constant and that constant is calculated with this formula where n is the dimension of this matrix, means the number of rows and the number of columns. Okay. So now is the question how to create this magic square. So for creating this, these are the rules, and if we follow these rules, we can create a magic square of any dimension. So let's see how to do this. So at first we are going to create the magic square for n equal to 3. Okay. So we are ready with a 3 by 3 matrix and the index of the matrix is here. 0, 1, 2 is the index for the columns and 0, 1, 2 for the rows. Now in a magic square, there are numbers from 1 to n square. Okay. There are numbers from 1 to n square and each box is filled with one of these numbers. Means for n equal to 3, there will be numbers from 1 to 9. Okay. Means 1, 2, 3, 4, 5, 6, 7, 8 and 9. So these numbers will be there in this matrix. Now is the question where to start. What is the starting point? So the rule for starting point is the first rule. See, the starting number 1 is stored at position n by 2 comma n minus 1. See, this is the index, this is the cell. Okay. Now see, n by 2, n is equal to 3. So what is 3 by 2? 3 by 2 is 1. This is the integer answer. So 3 by 2 is 1 comma 3 minus 1. So that is 2. Okay. So the first cell is 1 comma 2. So let's see the cell. See, first row and second column. So this is the cell and we have to keep the first number, that is 1, in this cell. Okay. And after we store 1, we have to go on filling the matrix with all these numbers consecutively. So let's see. So what is the rule for next position? Means for the next number, that is 2, what will be the position? What will be the cell? So see, if I comma j is the current position, means the current number, that is 1, if it is positioned at I comma j cell, means here 1 comma 2, then the next position will be I minus 1 comma j plus 1. Means see, what is I? I is 1 and j is 2. So it will be 1 minus 1 is 0 and j plus 1 is 2 plus 1, means that is 3. Okay. So the next cell is 0 comma 3. So see, what is the first cell? First cell is 1 comma 2, and what is the next cell? Next cell is 0 comma 3. Now let's search for 0 comma 3. So 0th row and third column. Oh, there is a problem. The third column is not present. That means there should be a rule to find the position if the jth column is not present. Okay, so let's see. So that is the fourth rule for j. See, if j is equal to n, then j becomes 0. Okay, that means here j is equal to n because n is 3. So that becomes 0 comma this 3 becomes 0. Okay, so now we have to keep the next number, that is 2, at 0 comma 0 position. So 0 comma 0, and you have to keep 2 there. As we go further, you will perfectly understand all these rules. Okay, so let's start solving. The current position is 0 comma 0. Now what will be the next position? See, for 0 comma 0, it will be 0 minus 1, that is minus 1, and 0 plus 1, that is 1. Okay, see, 0 minus 1 and 0 plus 1. So see, let's write here the next position is minus 1 comma 1. So now minus 1, see, index minus 1 is not present. Index minus 1 is not present. So the third rule, if I is equal to minus 1, then I is equal to n minus 1. So see here, this minus 1 will be wrapped into n minus 1. So what is n? N is 3. So 3 minus 1 is 2. So 2 comma 1 as it is. J is present, but the problem was with I, and this I has been wrapped into n minus 1, means 2. Okay, now I will tell you exactly what we are doing. This is the circle which makes it very simple to find out the next position. If any position goes out of order, then you have to just see at this circle. Now as I is decrementing for next position and j is incrementing for next position, so you know that I is going in anti-clockwise direction and j is going in clockwise direction. Okay, so as j is going clockwise, that means after 0 value of j will be 1, after 1 value of j will be 2. Okay, but after 2 the value of j will be again 0, but actually value of j after 2 will be 3 because 2 plus 1 is 3. Okay, you can see here, see, if j is 2, then after 2 the value of j will be 3, but 3 is not present in our indices. So you follow this clockwise direction in this circle. So after 2, the value of j will be 0. Okay, means 2 plus 1 is 3, but this 3 will be wrapped into 0, the next value in this circle. Okay, now let's see for I. Now for I, as it is decrementing, if I is 2, suppose I is 2, okay, then what will be the next value? It will be 1. So if I is 2, then the next value will be 1. Then again, if I is 1, then the next value will be 0, okay, for I. Now if I is 0, then the next value will be minus 1, okay, but minus 1 is not present, so it will be wrapped into the next value in anti-clockwise direction. Okay, so after 0, the value of I will be minus 1, but it will be wrapped into n minus 1. Okay, what is n? 3. 3 minus 1 is 2. So it will be 2, the next value in anti-clockwise direction. Okay, so just keep the circle in mind. You will not need to calculate every time these two rules. Okay, so just keep this circle in mind. For j, 0, 1, 2, and if j exceeds 2, then it will again become 0. And for I, 2, 1, 0, and if it becomes less than 0, then it will again become 2, okay, and then again 2, 1, 0, again 2, 1, 0. Just keep this circle in mind. So let's go ahead now. So let's keep the next element, that is 3, at position 2, 1. As you know, we found out the position. So at position 2, 1, let's keep 3. Now the next element 4. Now see, 2, 1 is the current position. So what is the next position? If it is 2, 1, so let's see the next position. 2 minus 1 is 1 and 1 plus 1 is 2. So 1, 2, 1, 2. So see here, this is the cell where we have to keep 4, okay, but this cell is already occupied. There is an element already present there. So in that case, this is the rule, the fourth rule. If the position is occupied, then I is equal to I plus 1 and j is equal to j minus 2. So let's see what is the position, 1, 2, okay, but this position is already occupied. So what will it be converted into? I is equal to I plus 1. So I is equal to I plus 1 is 2. So means 1 plus 1 is 2. And j is equal to j minus 2. Means 2 minus 2 is 0. So 2, 0 is the next position. Okay. So you have to keep 4 at this position. Right. Now let's go ahead. So 2, 0 is the current position, and now you have to keep 5 at the next position. So where should we keep 5? See, 2, 0 is the current one. So 2 minus 1 is 1, 0 plus 1 is 1. So 1, 1 is the next position. Okay, so we keep 5 there. So what was the position? It was 1, 1. Okay, now let's go ahead for element 6. Okay, so 1, 1. So what will be the next position? 1 minus 1 is 0, 1 plus 1 is 2. So 0, 2. Okay, so here it will be 6. Now what was the position? It was 0, 2. Okay, now let me just make space here. So the current position is 0, 2, 6 is placed at 0, 2 position, and we are going to find out the next position. See, 0, 2. So what will be the next position? 0, I minus 1 is minus 1, comma, j plus 1 is 3, minus 1, 3. Now this is a special case. See, the next position is minus 1 comma 3. Okay, so this is a special case now. So what is that special case? See, the case is that at the same time or at the same instant both I and j are out of bounds, are out of the indices. Okay, I'll write it here, out of bounds. Means I is out of bound, it has become minus 1, and j is also out of bound, and this has become at the same instant, at the same time both I and j are out of bounds. Okay, so in this case you have to go at the fifth rule. Okay, means see, if I comma j is minus 1 comma n, means minus 1 comma 3 in this case, because n is 3, so it will be minus 1 comma 3. So if it is minus 1 comma n, then it will be converted or it will be wrapped into 0 comma n minus 2. So what in this case? See, as the value is minus 1 comma 3, so in this case it will become 0 comma n minus 2, means 3 minus 2, that is 1. So the next position will be 0 comma 1. Okay, so see, so the minus 1 comma 3 will be converted into 0 comma 1. Okay, so now is the time to tell the difference between the fifth rule and the third and the fourth rule. See, for the third and the fourth rule, I and j were not becoming out of bounds at the same instant. They were separate. Okay, sometimes I was out of bound but j was valid, and sometimes j was out of bound but I was valid. Okay, means either one of them were going out of bounds, not both at the same instance. But for the fifth rule, both are going out of bounds at the same instant. Okay, so that is the difference in these two rules. So 0 1 is the next position, and you have to keep the next element, that is 7 there. Okay, now let's go for the next element, that is 8. Okay, find out the next position. So 0 1 is the current position. So let's see, 0 minus 1 is minus 1 and 1 plus 1 is 2. So the next position is minus 1 comma 2. Okay, so minus 1 comma 2 means, just remember the circle now. For minus 1, as it is in anti-clockwise direction, I will become 2, and for 2, as it is valid, it will remain 2. Okay, so 2 comma 2, and 8 will be kept there. Okay, so now what is the next position for element 9? The next element, see, as the current position is 2 comma 2, it will be I comma j, and what will be the next position for that? See, 2 minus 1 is 1 comma 2 plus 1 is 3. So the next position is 1 comma 3. Okay, but now here 3 is not valid and it exceeds 2. So as you know, in the clockwise direction, if j exceeds 2, then it will be wrapped into 0. So 3 will be wrapped to 0. Okay, so j will be 0 and 1 will be as it is because it is valid. So the next position is 1 comma 0. So 1 comma 0 and 9 will be placed there. So this is the magic square, and we have completed all the values in this magic square. This was for n is equal to 3. You can create magic square for n is equal to 4, 5 and for any dimension. You have to just follow these rules. Now the third and the fourth rule will change according to the dimension. See, If n is equal to 4, then it will be 0, 1, 2 and 3. Okay. After 3, if j is 4, then it will be wrapped to 0. And if I becomes -1, then it will be wrapped to 3. Okay. So the circle will be like 0, 1, 2, 3. If n is equal to 5, then the circle will be, see, 0, 1, 2, 3 and 4. Okay. So this will be the circle. So this is how we create magic square. So please practice creating this magic square for n is equal to 4, 5, 6, 7, so that you can perfectly understand this concept. Hey friends, please subscribe to my channel as I post algorithm videos every day. And if you want a video on any particular topic, then please mention in the comment below. Thank you.